Good morning, everyone. Thank you for your time to attend this webinar meeting today. Today, we're going to cover the clean room air quality monitoring solutions. By the way, my name is Norio Kobayashi, which is not written here on this page. I'm taking over the last Isaac because the just audio doesn't work good now. So I'm going to speak about the brief presentation about the HORIBA introduction. And after that, the Kyohei Nishizawa, who is the product specialist from Japan, he's going to introduce what the HORIBA air, AMC air clean monitoring solution presenting here. So if you have a question, you have the chat box, and you can put your question in there. So we are going to go through that question later after this presentation. So let's get started. So before we start the presentation, just want to let you know, give a heads up that we have social media. We have the YouTube video is presenting a lot of webinars we have done past, like a SEMS applications or process gas monitoring station, or the system integration, stuff like that. So if you are interested in that, any type of the measurement, maybe you can take a look, and please subscribe and be updated always. And also we do that in Facebook channel, the Twitter, and Instagram, and the LinkedIn as usual. And we're trying to keep you guys updated with those social media as well. All right, here is the agenda. Who is HORIBA, and also let you know that what the HORIBA capability from Houston in the United States, and also give you some brief introduction of the products we are covering. And finally, the Kyohei Nishizawa is going to give a presentation for clean room air quality monitoring stations solutions. And then finally, we're going to go through the Q&A session, and that's about the 15 minutes to 1 hour session. This is a HORIBA worldwide. We have the many branch offices in the world, and we founded back in 1953 at headquarters in Kyoto, Japan. Our domain of the business is analysis and measurement technology. We have more than 7,000 employees worldwide, and we have over 49 global locations. And we made about $2 billion USD in sales back in 2018. Next, please. And a quick business updates from our domain. We have mainly 5 business segments. One is the automotive test system. We are providing the emission system for all of automotives. So the car manufacturer is having the testing to pass all of the certification or each country's requirements. And we have in pretty good shape in the market share in this industry. And the process environmental is also the other aspect of the analyzer, measure a lot of emission gases from the plant or ambient air, or the waste water, stuff like that. So we're contributing the environmental pollution protection and by analyzers. And medical is another aspect to need measurement. We measure some blood testing, things like that, and selling those solutions to these small clinics. Semiconductor is kind of the touchy with, we're touching this area today. Today we are focusing on the more like ambient air monitoring in this clean room. However, we do that, the semiconductor monitors, like the mass flow control or wet process monitoring, things like that. We have a pretty good shape in this industry as well. And scientific requires many laboratories instruments and X-ray instruments, ICP, things like that. We have those instruments too. So as you can see that all of the 5 segments is touching the analyzer world. So any type of analysis requirements, we're happy to help with us. That's basically HORIBA domains. Next, please. All right, let's talk about America. We have more than 16 locations in America, but our headquarters is located in California, in Irvine, and we have just opened the HORIBA Instruments Inc. in Pasadena, Texas, which is the close to Houston's major city. We have a lot of parts inventory in Houston and the manufacturing analyzer and the integration of the system analyzer system in Texas. So more capability in Texas and close access to the lot of oil and gas industry and also the power plants and the chemical industries, and we're going to introduce about the clean monitor system into the semiconductor field. All right, this is the HORIBA Houston. Back in 2012, we have acquired a company named Cameron Process, which is founded in 1985. They were system integrators located in Houston, and which is handling the bunch of analyzers and they build own sample system or integration into the shelter or analyzer rack. So we were analyzer specialties, and we are having the more capability to assemble with the other analyzers combinations. So more and more solution is available now from Houston base. And we have 100% HORIBA employees, so the craftsmanship is always quality first. So we are providing those turnkey solution now. This is the major items, major top 3 items what HORIBA is providing. As usual, HORIBA provides the analyzer, and plus we are providing the analyzer shelter as a turnkey solution, including the engineering or designing, the fabrication, and all project documentations. And we do that the field service and also embedded service contract, so that we can keep the analyzer in healthy shape and up running. That is the type of things we are doing in the field. And also some of the SEMS owner knows about maybe part of you guys may know that the RADA testing. This is a relative accuracy test audit. All of the SEMS owner needs to pass their own SEMS unit every year. We have a trailer, and we have a crew specialties, and do that the RADA testing as well. Okay, more factory capabilities of capacity. We have a huge factory in there where is it available to build up to like 20 shelters inside of the building, and we do that the sample system construction, rack construction, and HORIBA analyzer integration. Of course, we can handle the not HORIBA analyzer integration as well. So any type of requirements, including the bunch of brand analyzers, we're happy to mount them and integrate them into the system and provide the customer with as a turnkey solution. Next, please. This page is showing the couple of analyzers. Process gas analyzer GA-370 is measuring like a trace gas monitoring, like a low concentration of CO in hydrogen background, or the CO2, methane in air separation application, stuff like that. And also ambient air monitor, which is the AP-370, which is what we are focusing on today. and the process gas analyzer, semis analyzer, and the portable gas analyzers. So we have many analyzers, many type of analyzers in our portfolio. So if you have any type of requirements for your project, we are happy to help from here. All right, I think that's all, and I want to pass it to Kohei Nishizawa. He's going to present the clean room air quality monitoring solutions. There you go.
Yeah. Hello everyone, I'm Kyohei Nishizawa of HORIBA Limited Japan, and I'm doing the product specialist of ambient pollutant monitor. And today I'd like to talk about HORIBA solution for semiconductor industry, and a particular focus will be given on clean room air quality monitoring. HORIBA, as a manufacturer of analysis instruments, has been providing solutions for automotive industry, semiconductor industry, or scientific field, medical industry, and the process environmental field, as explained earlier. And the solutions are centralized around the core technologies of gas flow control, infrared measurement, spectroscopic analysis, particle size distribution analysis, and electrochemistry. With the utilization of the technologies, HORIBA provides total solution inside the clean room and also outside clean room, such as for utility management. Now, let me first talk about HORIBA solution inside the semiconductor production process. Firstly, in cleansing process of silicon wafer, we have solution to check chemical concentration composition, silica, and dissolved oxygen in ultra pure water. The HORIBA XRF technology also helps you to check metal contamination monitoring in chemical solution. In deposition process, solution for optimization of chamber cleansing by real-time gas distribution monitoring. Also, monitoring and evaluation of film thickness, uniformity, and film quality by UV visible spectroscopy and laser scattering will contribute to the optimization of process parameters. And in etching process, in a deposition process, accurate fluid control of gas and liquid with great repeatability is also essential in deposition process. And further process key factors are better controlled by measuring pressure, plasma, and discharge gas concentration inside the chamber. Now, in etching process, monitoring trench depth and interface will assist you to control proper plasma etching endpoint. And by monitoring plasma condition, you can optimize the chamber cleaning management. Uh, in lithography process, particle detection system will help you in detection and automatic removal of foreign substances on reticle and a mask. In CMP process, particle distribution monitor provides optimization of slurry efficiency by ensuring the homogeneity of slurry supply. Afterwards, analysis of uniformity of metal thickness would detect the failure of electric connection. Now, let's walk out from the production process and take a look at the HORIBA solution for facility management. For water wafer stage, mass flow controller provides you proper nitrogen purge flow for natural oxidation control, and also a real-time impurity monitor of pure gas will provide you continuous, stable, high-sensitive monitoring of ppb level to ensure the quality of pure gas supply. To comply with the environmental requirements and work environment safety, HORIBA provides continuous monitoring systems for a variety of gas and particle discharge. And not only the gas discharge, but for water effluent regulation compliance, HORIBA provides inline industrial monitors for key parameters too. And finally, but not the least, HORIBA provides continuous monitor of the gas-formed impurity molecule for optimization of semiconductor manufacturing environment. Okay. Now, let's take a closer look at the manufacturing environment monitoring. And today's focus is particularly on contamination called AMC. Uh, Airborne Molecular Contamination, AMC for short, refers to a molecular compound of damages to the product that potentially exist in clean room. The observed negative effects of AMC are the chemical reaction of a product surface, such as microcorrosion, uh, oxidization, or change of pH value of a surface. AMC is often classified and grouped in relation to the main chemical nature of the contamination compound or its observed effect. Typical groups are acids, bases, condensables, and dopants. However, it should be noted that specific compounds can be related to more than one of the above-mentioned groups, as their interaction with the product may depend on the product state and place of impact. MC has various potential sources that can be sectioned into being located outside of the production building or clean room and inside the clean room or production environment. And identification of the sources for AMC, the transport pathways and generation source is of the highest importance for a proper and stable control of the clean room production process, which leads you to define appropriate solutions and prevent negative effects on production. All right. One of the ways to identify AMC level is impinger method, which starts from taking the sample air into the absorbent in the impinger. Remain the sampling time for a certain time period and concentrate the target element. After you get the adequate sample, you take it to the lab analysis. 1.1 manual analysis leaves you a difficulty in identifying the AMC transport pathway. Um, Limited time point data doesn't tell you rapid outbreak of a specific AMC, which is essential in identifying AMC generation sources. Those are the challenges that the conventional manual method contains. And here is the HORIBA solution, automatic AMC monitoring system. The image on the right side is an example of the system. It comes with the analyzer unit, and line selector and operation panel. Depending on your request, the system can be configured to select multiple measurement points. And you can manually select the measurement point at the display, or you can externally control the switching sequence automatically too. By installing the continuous monitoring system, you can detect a rapid outbreak of a specific AMC contamination in high time resolution, which helps you to trace back to possible AMC generation events, including outside environment change, specific event inside clean room, or chemical filter deterioration, which helps you identify AMC transport pathway and generation source. Also, multiple points measurement will provide you essential information to specify the location of the AMC generation source or transport pathway, which helps you identify, uh, which help you define appropriate solutions and prevent negative effects on production. Right. The most important technical aspect of the monitoring system is the analyzer. For AMC monitoring system, HORIBA tuned globally proven ambient quality monitor AP-370 series for clean room use. Ambient quality monitor is one of the fields where reliable quality, robustness, and easy operation are required to provide accurate data 24/7, 365 days, since the data is critically important. For example, for government sectors to make investment decisions for environmental, industrial, and political issues. And HORIBA has been providing more than 10,000 AP series for air quality monitoring stations from decades ago. And during production, QA/QC of the core parts of optical units, such as detector, light source, measurement cell, and even optical filter on its own factory. Next, let me talk about measurement principle used for the analyzers. For NOx, NO, NO2 ammonia, chemiluminescence is used. The chemiluminescence method uses the reaction of NO with ozone. A portion of the NO2 generated as the result of the reaction becomes excited state. As these excited molecules return to the ground state, chemiluminescence is generated in the range of 600 nanometers to 3000 nanometers light wave length. The light intensity is in proportional to the concentration of NO molecules, and by measuring the intensity of the chemiluminescence, NO concentration of the sample is obtained. For NO2 measurement, the deoxidization unit converts the NO2 into NO, and NO is measured likewise. If your interest is ammonia, we use a special catalyzer unit to convert ammonia into NO, and measurement goes on the same way. The three solenoid valves installed in the drawing continuously switches the three flow lines. In the line with NOx converter, NO and NO2 are both detected as NOx, and only NO is detected in the line without the NO2 converter unit. The reduction of the NO value from the NOx value gives you NO2 value. The last line is the reference line, where reference gas is introduced. Most conventional method uses reference cell to compare 0 point. On the other hand, by only using one cell, by always introducing pure nitrogen, concentration is always cleaned up and provides you remarkable 0 point stability for a long time. For SO2 and H2S measurement, UV fluorescence is used. When a sample is irradiated with ultraviolet radiation of 215 nanometers, SO2 emits fluorescence, and the intensity of the fluorescence is proportional to SO2 concentration. And if your interest is H2S, we use H2S converter unit, and it is measured as SO2. Okay, for ozone, the technology used is non-dispersive ultraviolet. And ozone has characteristic light absorption range at a specific wavelengths at 253.7 nanometers. So the deterioration of the UV intensity at the detector is proportional to ozone concentration. Again, for AP-370, HORIBA unique cross-flow modulation design is used. Let me explain the general specification of the analyzers for Cleanroom special use. For ammonia monitor, we provide model AP-370 as analyzer and model CU2 as a converter unit. Measurement principle is cross-flow modulation chemiluminescence. Measurement range is from 100 to 1000 ppb. Lowest detection limit is 1 ppb. The response time is 300 seconds, and data availability is every 1 second. For NOx NO2 and NO monitor, we use model AP-370 as analyzer and also O2 generator unit to further optimize chemical reaction of NO and ozone. Measurement principle is cross-flow modulation chemiluminescence, and measurement ranges from 10 to 100 ppb. For this one, lowest detection limit is 0.1 ppb. The response time is the same as the others. Okay, for SO2 monitor, we provide model called APSA-370 as analyzer. Measurement principle is UV fluorescence, and the measurement range is from 10 to 100 ppb. Lowest detection limit is 0.1 ppb. For H2S monitor, we provide model APSA-370 as analyzer, and we use converter unit CU1. Measurement principle is UV fluorescence, and the measurement range is from 10 to 100 ppb. Lowest detection limit is 0.1 ppb. And finally, but not the least, for ozone monitor, we provide model APOA-370 as analyzer. And measurement principle is cross-flow modulation UV absorption. And measurement range is from 100 to 1000 ppb. And lowest detection limit is 0.5 ppb. Okay, now let's look at how the trend data in high time resolution by continuous monitoring will help you in the actual AMC management. This is an example of a trend graph in a day for NOx, H2S, and ammonia. You can clearly capture the outbreak of a target AMC compound. And if you look at the trend graph, you can find uh, uh, the concentration of H2S and NOx started gradually increasing at 5 a.m. and making a peak point at 9 a.m. And NOx and H2S are showing peaks again at 7 p.m. and also at the midnight. And since they are rapid increase and concentration in normal condition seems as stably low, defining defining its cause is deterioration of chemical filters doesn't seem proper. On the other hand, the first two peaks happened during certain time periods. And if you think of possible contamination generation events outside the factory, um, they seem to agree with rush hour, where more traffic of vehicles is expected. And if you have the trend data for another day, and if it is also showing the similar content, it will further support you to define the contamination source. And based on the earlier mentioned theory, you can start a further investigation of the AMC source apportionment. In such way, the trend data in high time resolution by continuous monitoring will support a proper stable control of the clean room air quality. Next, let's look at the AMC transport route example. The outside ambient air is taken into the conditioning system, going through pre-filter, washer, cooling coil, filters. And if the AMC contamination is not removed properly at this point, you have to take counter actions already. And the air in clean room is circulated, but there could be a spot where AMC concentration tends to be concentrated over time. For example, for ammonia, an area with many people tends to be the spot. Likewise, from the outside ambient air intake to the southern areas inside clean room, there are multiple locations where MC concentration tends to be high and the key indication of the source apportionment. So as to satisfy that, multiple points measurements are employed in many cases. For multiple points measurement, HORIBA provides typical three-type system configuration. And the first one is standalone multiple system. The multiple monitoring systems are installed at each measurement point and data is transported to the central controlling room. Advantage of this configuration is you can have the continuous measurement data in each 1 second for all measurement points. On the other hand, if you prefer monitoring specific point for a certain time period and switch to other points, we have multiple points line selector solution. In this way, multiple points are monitored by one AMC analyzer system. Another configuration is movable standalone system. If you only need to monitor a specific spot occasionally, for example, when a suspicious event happens, you can have the AMC monitoring system installed on a movable rack, and you can manually bring it to the measurement point upon your demand. Okay, this is the last slide of my presentation. Let me summarize the benefits of the automatic AMC monitoring system once again and close my session. By installing the continuous monitoring system, you can detect rapid outbreak of a specific AMC contamination in high time resolution, which helps you to trace back to the possible AMC generation events, such as outside environment change, specific event in cleanroom, or chemical filter deterioration. And also multiple point measurement will provide you essential information to specify the location of the AMC generation source or the transport pathway, which helps you to define appropriate solutions and prevent negative effects on production. Okay, if you're interested in any of the HORIBA solution, please feel free to contact us. Thank you very much.
All right, thank you, Kyohei. It was very interesting presentation. Um, so that's the today's presentation, and I don't see any the major questions at this moment. But if you have questions, please don't hesitate to put in the chat box. I can see one of the requests. It would be really great. This is the from Abdul Wahab. He said it would be really great if we can have slides or recording of this session. Yes, HORIBA is going to post this video for that webinar, on YouTube, so you can take a look at the session on YouTube video. And also we have the multiple webinar sessions on YouTube posted already. So if you can find any interesting video, please take a look, and you can subscribe it so you can be notified when we upload it. All right. I don't see any other questions yet. Not sure if somebody is typing right now. Thank you. All right. No questions so far. So you can get the contact information through the invitation. And my name is Norio, and the Lance Isaac and the Mick is the regional sales manager. You can contact us for any inquiry or any other question. So that we can follow up from there. All right, I think looks like that's it. And I hope you have a great day today. And I hope to see you again on YouTube or webinar. Thank you so much. Kohei, again, thank you so much for your presentation.
Thank you.